Hi, this is Chris Ball from Mashpee TV with another Mashpee update. Today I have with me Jared Meader, our superintendent of the wastewater department. Gerard is fairly new to us, coming here from November. Gerard, welcome. Thank you very much for coming. On Friday, Mashpee TV went out and took a tour of our still under construction, but very well along the way, our $30 million wastewater plant that will be starting up hopefully within the next year. So Gerard, I'm going to turn it over to you pretty much. Tell us about yourself, where you come from, your background, and then take us through the tour we took on Friday.
Okay. So like you said, my name's Jared Meader. I got in water about 15 years ago or so in the wastewater field. I actually was a reverse osmosis wastewater operator in the Army. Prior to that, I was in the Marine Corps for 6 years and did a couple tours in Iraq. Came back, I was in the law enforcement field and just wasn't a good job that I wanted to do anymore, so I started a new career path in wastewater. Took a tour of the plant and was like, this place is amazing. So many things to play with and break, and really got into the field. After about 4 years, my boss retired, so I stepped in as the interim superintendent and did that for a few months. And then an opening came up in Tisbury as well as in Oplus, and I applied for both, got offered for both, and decided to go to work in my hometown. Was a superintendent there for approximately 3 years, at which point we decided to leave Martha's Vineyard and move to the Cape. And so we moved to Centerville, and I was commuting for about 6-8 months, and then saw the opening here in Mashpee, and so that's close to home, and it was a brand new facility, and it uses MBR process, which is a lot like the reverse osmosis, just not as stringent. So I put my name in the hat, and I like to say I got lucky and got the job. It's been an awesome experience so far. Coming from an island, you would think that people would rely more on their natural resources and protect their fresh water supply, because we just can't connect a pipe to the next town and make up for our losses. And here, people are more proactive. They really are addressing the issues. Just recently, I threw an idea out there about this, Pimlico Pond Road area, something that wasn't addressed in the CWMP, and people latched onto it right away. Thought it was a great idea, and so it's very encouraging. It makes it fun coming to work every day. Everybody's thinking outside the box. Everybody's working together. I was most impressed with the fact that since the passing of Ray Jack, instead of the project kind of just stalling out, every department took a piece of it, whatever one was closest related to them, and just kept the project moving until I got here. And everybody's been helpful since I've been here.
That's great. So you're originally from the Vineyard.
Yep.
And then spent 18 years in the service?
Total 18 years, yep. Six Marine Corps, 12 Army. So 2 tours in Iraq. Thank you. Thank you. It was a good chance to get a lot of experience. I always joke around and say, my education, I have a PhD, a plain high school diploma. It's always my joke. But it taught me the ability. I think I would have wasted my parents' cash if I'd gone to college right out of high school. And they taught me how to research things, how to have a go-get-it attitude. I can't do it, just always, figure it out. And I think it benefited me in this job. And I always research what somebody tells me. I never claim to be the expert. I love listening to other people's ideas. And then I go research on it, give me a new path and I'll go research it. And I think with everything that's going on now, that's very important.
That's great. So, as I said, myself and Justin from Mashpee TV, you were great, took us on a tour of the new plant on Friday. So take us through what we saw, where we are on that sort of thing. And as you know, we took a lot of video, and we'll fit that into what you tell us today.
Okay. I'll start it from front to end, how everything comes in. Starting at the plant, of course. And we started with the pretreatment building. The first part of that is when the waste comes in, it's mixed in with a lot of stuff. People flush a lot of things they're not supposed to, and things that they're supposed to but just aren't good for an MBR system. And so the pre-treatment building, what it does is it takes that wastewater, that first load that comes in, and then basically removes like toothpicks, baby wipes, eggshells that could have gone down the drain, anything like that that could potentially damage the membrane later on down the line. So it goes through a 6 millimeter strainer first, where basically it goes to the screen and then it captures everything and it goes up a conveyor up to the top, where during that whole trip up the conveyor it's getting washed with high pressure water, and then ultimately just goes in the trash and gets disposed of at the dump. Then it goes through a grit chamber where it spins the flow and all the heavy grit will fall out, and that can be anything, sand that was left in the pipe. People take a shower after the beach and the sand goes down the drain, so all that sort of stuff is removed in there and gets removed out. And then it goes to a 2 millimeter screener, much like the first one, same exact principle, but it's just taking out really fine stuff. So we started in there. I gave you guys a tour of the electrical room, which is pretty impressive. We saw the thick wires.
Very impressive.
Yeah, all the a lot of juice goes into that building. It's very energy consuming in a good and bad way. It's mainly one part, but what you guys were looking at was the automatic transfer switch, and the plan is designed that when power outages happen, this switch will automatically, after so many seconds, kick over, and it's really loud. And if you're standing next to it, it'll make you jump because it's a loud bang. But what it does is it flips this huge breaker and transfers us to generator power on the plant. So it's always running.
What was very impressive to me was the buildings have been built out so that there's room in all areas that I saw. That phase 1 is obviously taken care of, but there's room for phase 2, phase 3, so on down the line. That yes, there will be more equipment needed, but the space is there, and a lot of the infrastructure is already there that's being built out now.
Yeah, that is the one thing that probably impressed me the most when I physically saw the plant. So every plant I've been to, you always talk about, oh, this is where the future SBR is going to go, or this is where the future clarifier is going to go. And there's nothing there but land. I like to use the term, it's never cheaper than it is today. And here, that was a prime example where they took that big cost, the pouring of the concrete, the digging the holes, putting in the pipes. You could always do that later, but you got to re-dig up things. You got to make different connections in pipes and reroute things. The town built that in the first stage. So like for example, in the pre-treatment building, you have the 6 millimeter screen, only one of those. Then it goes to the grit chamber and the grit classifier, and then it goes to the 2 millimeter screen. Now that screen can handle in itself 1.2 million gallons per day. But we have a knockout wall they put in there, and they already poured the channel and everything for us to be able to, in the future, put another screen if we need to. Again, going forward into the membrane chambers or the reactors, you have 2 trains that run parallel in phase 1, but we built all 4 trains. So you have 1.1, 2.2, so on to 4.4 or 4.2. And that, again, that's all the expensive stuff that is only going to get more expensive as time goes on, taken care of now. And they can sit and not be used for a couple of years without damaging it, unlike a lot of equipment has to be run. Then all we have to do is, like in phase 2, we're just going to bring in the equipment that actually does the process, put them on their skids and their mounts, connect the pipe, and we're off and we're going. So it's a lot cheaper going forward in the different phases.
So we were in the electrical room.
Yep, so in the electrical room, we talk about the transfer switch. After that, we go to an equalization tank, and the way it's designed is that, obviously in the middle of the night, we don't have a lot of flow. And then during the daytime, usually in the morning about, between 7 and 9 a.m., everybody's getting ready for work, so showers, toilets. So we have a tank that when that flow starts coming in really heavy, so we don't overflow our tanks, it's a big tank that just kind of allows everything to be able to sit there until the process can actually take it. So we got the equalization tanks. From there, we went inside, we saw the chemical feed room. A lot of that has to do with odor control. It has to do with pH balance. That's very important because ultimately what people don't realize, you see those industrial equipment, and all we're doing is using bacteria, natural bacteria, like it would happen in the environment if somebody was to go to the bathroom on the ground. We're doing that same process, but instead of taking weeks for this to happen, we're doing it in hours. So all this infrastructure is nothing more than to provide the ultimate or optimum environment for the bacteria that's going to dispose of the waste ultimately. So that's what a lot of those chemicals are used to keep that pH environment where they can survive appropriate. From there, we went into the blower room. So most of what regulates this process at the end of the day is air. Air is extremely important for the bugs to survive, and in a very simplified version of what the treatment process is we have the bugs in there, and they're basically, let's say they're sleeping, or they're not very active. They're depleted of a lot of air, there isn't a lot of food. Then we bring in the food.
Let me interrupt you a second.
Yep.
So this is something I asked you to clarify when I was there.
Mm-hmm.
Tell us about the bugs, that they are actually bugs, and how they come about and how you rotate them out.
Yeah, so the bugs they're natural in our bodies. In the waste, when it sits, it takes life cycles about 15 to 20 days. They will naturally form. You'll end up with these little free swimmers, and they're just little. They almost look like fleas, and they just run around the waste particles if you look at it under a microscope, and they're just eating as they go. As they evolve, they go into what they call like a stalk ciliate, and it basically has a head with a little tail, and it'll attach itself to a what we call flock or a mass of the waste, and then what you look for ultimately is what we call a colony, and you'll have a whole bunch of these just connected, and you see this big, giant mass of these ciliates, and they basically just connect themselves and they filter water through, and they just filter, and as it comes in one end, it goes out the other end clean. And then later life forms or older is we get rotifers, and rotifers are I always look at them under the microscope, and they're kind of like, if you could picture being that small, they would scare the crap out of you, because they're like a long worm, but they have these two spinners at the end that just constantly go, and they just pull in waste, and they can move around. They have a tail that latches onto whatever they're holding on to anchor, and then if they use up all the waste there, they can move along to the next mass. Later on, you go into things like water bears, which is the most, and people have probably heard the term many times in their life, and they've never really stopped to listen to what it is, but they're the most amazing creature. It literally looks like a little bear with a snout, and just recently they discovered that when they brought them up into space, when you took it out of the environment and put it into open space, it basically created a shell around itself and went into a hibernated state. And then when they brought it back inside and put it in its optimal environment, it shed the shell and was still living. They're like indestructible. They're amazing. Those are later life forms. We try not to get those. That usually means we're not wasting enough. So ultimately what we do is we raise the bugs from scratch. We let them stay around for a few weeks, and at the end of every cycle, daily, multiple times, we're getting rid of the older waste, and we send that sludge out to be either incinerated or turned into landfills, many different ways to get rid of it. But that is the life cycle of the bugs, and really all they do is just sit there all day long and just eat it. And the air, that's where I want to get back to, is the air is what makes them work. So like I said, they come in, they're sleeping, we bring in the food, we kick on the air. It's like giving them a shot of adrenaline, and they work like crazy. They consume air, they consume the waste, and then once the air gets below a certain point, they go back to sleep, and we get rid of the whatever's left over through the sludge. And then once they go to sleep, we bring in the next load, we turn on the air again, we wake them up, and they get to work like crazy. There's always a balance with the air. If you put too much air, you can end up with what's called filamentous bacteria. It usually is produced with grease. That's why we don't like grease going down the tanks. But when you add the high air, the bacteria grows, and it will eat the oxygen that's in the tank quicker than our bugs can eat it. So it seems counterintuitive. It took me a while to wrap my head around the fact that we need to give air to the bugs. So if we get too much air, they don't get air, and it's because the bacteria will eat it first, and then it ultimately will kill our bugs and take over the plant. So we're always balancing that out, checking it out. So once the waste comes in and it goes into the tanks, you have what's an anoxic zone. That's where they're sleeping. Then we bring the waste over to another area, and we give it air, and it's our aerobic zones, and then we go back into anoxic zone to kind of allow everything to settle out. And it's a constant process. From there, it goes into the tank that has the MBRs, which is these filters. It almost looks like straws, a bunch of straws in a row with a membrane around it, and it sucks the water through, and that's where the energy comes in. It really has to suck the water in. And then after a certain amount of time, there will be little masses of flock, we call it, are wrapping around the straws, and it gets too hard to suck. So then the machine will automatically say, okay, we get too much pressure here. It'll do what's called a backwash, and it'll take a clean tank of water that we have, which is already treated water, and backflow it and push everything away from that membrane. And then it'll start the process up again. And after so many times, then we do what's called a detergent bath. And we basically put citric acid in there, let it sit, and eat all that stuff in there, and it keeps the process going. From there, it'll go into a UV disinfection, which is a bunch of light bulbs set at a certain wavelength, that as the water goes through, people worry about viruses and stuff like that. So what this UV wavelength does is it doesn't actually destroy the virus, it destroys the virus's ability to reproduce at the cellular level. No matter what we do in life, every time you touch a surface, you're getting a virus or a bacteria. And that's not what hurts us in general. What hurts us is after we ingest it with our hands, eating, something like that, is its ability to reproduce inside our body. And once it starts reproducing, we get sick. Since COVID, everybody knows about viral loads and things like that. So it's the same thought process, but here what we're doing is using that light to make it so that it can't reproduce. And that's what keeps us healthy. And we do these tests called fecal coliform tests. From there, it goes out to a D-box. And in the D-box, which everybody has with their septics in their yards, and it tells us which field we're going to dispose of this waste at, or this treated water. And they're giant sand beds. We have 4 of them out there that we put in this phase. And like the septic, it'll get in the sand, and you'll never see a pond if everything's working right and we do our jobs. And it'll just go through the sand and go back into the ground.
And these pools are massive.
They're really big.
Really, really big.
Yep.
I would say like football size big. Football field.
Two of them together, yes, would be a football field.
So there's 4 of them, and
yep.
According to what you told us, really only need 3 operating at a time so that you can be doing maintenance on another and that type of thing.
Yes, that's one of the things that's with wastewater is even though the process is for the most part very automated, the work for us really is doing the labs, making sure we have that balance, replenishing chemicals, preventative maintenance. All those pumps and motors are constantly running. We got to grease them. We got to do repairs to them at very specific intervals. And then things like that sand bed. You got to go out there and you got to weed it because you're putting water in there that does have less than 5% nitrogen in it. Plants love that, and they'll just grow. So we're always out there weeding the sand beds.
But that water that's coming up and out of the plant is perfectly clean, sanitized down, and it's going back into the aqua filter system.
Yep, and then we let Mother Nature do what it naturally does anyways. The remaining nitrogen, hopefully a lot of it will get taken out, again, as it's going through the ground. A lot of the bacteria, it's like a filter in itself. And it just starts that process that we learned as kids about the water cycle and how it evaporates. The other area I showed you, which was pretty interesting, was the odor control system. So it's a 2-part system they put here because everybody worries about the wastewater plant smelling. There always is, so you should never get that rotten egg or septic smell. We are an aerobic system. We have air inside there designed to keep it fresh. I always say a good wastewater operator, and when I'm looking for water operators, is when people walk in there, I want to see them go, and most people are going to go, oh, that's horrible. But the wastewater operators actually can tell a lot from the smell. We use all of our senses but taste. That's one we frown upon. But all of our other senses we use because when you walk in the plant, just that smell alone, if you have like a sweet onion smell, could tell you there's ketones in the water. If it's septic, obviously it's not aerobic and it's bad. We look for a musty smell. We also look at color. Is it gray? We don't want white. White means filamentous, but we don't want black. Black means septage. So we use all of our things, but the odor control system, the whole plant is capped, even the tanks. So it will draw air into that system, and first it goes into what they call a biofilter. This filter is just a giant tank where we keep seashells is what we're going to use as a media, and we keep 30% humidity, or excuse me, 80% humidity inside the tank. So the air will go into the bottom of the tank, and then as it's drawing up through the seashells, bacteria in that 80% will attach, just like kind of like the bacteria we had inside the tanks, just a different form. They'll attach those seashells, and as the air passes through, it strips out the molecules that cause the odor. Goes from there, goes into a air scrubber or a charcoal filter, and so when it goes through there, activated carbon will also take out a lot of the smell.
And I got to tell you, folks, this thing is massive.
It is big. It's probably the one thing that makes it look industrial out there when you really look at it.
It's pretty massive.
Yeah.
So, the surrounding neighborhoods should not smell anything.
They should not smell anything. That's why we also keep the natural buffer around the plant, because nature in itself will do a lot of the work beyond what we're doing. And then plus we're going to have berms. The key thing is that the system is it's highly automated. It has a lot of redundancy, I guess is the word I want to use. We have multiple pumps for everything, so we should never have a situation where nothing is flowing inside the plant. Everything can be either manually bypassed, or we have a automatically wired in bypass, so whether it be a second pump that can kick on anytime, and they also work, whereas the flow comes in too fast, both pumps can kick on to keep up.
All right, so we know what happens to the water that's going into the pits. Now, what about the sludge?
Sludge we ship that away. It's currently we're going to do a wet sludge process. We don't try to take any of the water out of it. The only thing we might do is we have a what we call an unthickened tank. Heavy stuff sink, the light stuff float, and in the middle you end up with a pretty clear water. We'll throw a pump in there and suck out as much of that clear water as we can and stick it back through the process. But the stuff that we don't get, we ultimately just put inside a truck, have it vacked out, and then it gets sent away to different places like in Rhode Island or Maine. The tricky part is, like just recently, the Attorney General for Rhode Island is trying to stop any out-of-state sludge from coming into the state. PFAS is always the big concern. So it's getting trickier and trickier what to do with sludge. And if they incinerate it, a lot of times those incinerators are getting shut down either for maintenance or because of regulatory requirements, something happened. And it gets us nervous. Like, what do we do with the sludge during that time period? Because we only have so much tank space. So we do ship it away. Ideally, it'd be nice to see something local, local meaning within the state that's, more regional to handle the sludge, because it's a concern for every operator, especially on Cape Cod, what to do with it.
All right. So I realize from the meetings I attend and from our talk on Friday that we are still waiting for some back-ordered, very important parts and equipment. Do we have any solid idea of when this will go online?
We should be 100% operational by June 2025. The motor control centers, the MCCs, which basically is where all those big wires, where the electricity comes in, these are where they get to, and then they get distributed out to the pumps. It's where the breaker is. It's not really the brain of the plant, but it's kind of like its circulatory system. So it's those are what we're waiting on. There's a requirement now with American steel. We have to use, only American-made steel, and unfortunately, not all the companies that produce these have that certification. So we're limited to where we can get it from, and I'm sure everybody's using them. So kind of waiting our turn. They've told us it was going to be a 6-month delay, which put us to the January timeframe. But then some of the equipment they said was going to be delayed has already showed up. But other equipment hasn't. They're still saying it's going to be delayed, and in fact, they're saying it might be an additional 2 months. But even with that additional 2-month delay, the waterline, the company that's doing the work, actually went in there and started, instead of just waiting for the motor control centers there, they laid all the lines that they could before they got there. So when they come in, it should just be plugging them in and getting everything operational. So we are trying to anticipate, it being a little late, but the startup process, we do have wiggle room as far as shortening down. That's why if we lose a little, like a month maybe get them in February. It doesn't hurt us too bad because we laid out the startup time to be the worst case scenario, and we can always shrink in that startup time.
So those of us in phase one, I'm going to recap what we talked about earlier. Those of us in phase one, once the plan is ready to go,
Yep.
there's approximately 450 homes that'll be hooked up into that. Some of them condominium areas and whatnot. Once you're ready to go with the plant, you're going to start phasing in pieces of phase one, so that, it's not drop dead. Everybody's in phase one is going to get 90 days from the start. That you're going to phase it in, and as we go along, different groups of phase one will get 90 days, so that it's not a big influx, and that and if there's delays that can't be prevented, there can be extensions granted if necessary.
Yes, so when we start up, we have a 3-phase startup process, each one of them approximately 30 to 60 days, most likely 30 or less. But we'll start out with a clean water test, and that's just to make sure that, when people were putting the pipes together, they used the right amount of glue, they tighten the bolts so nothing leaks on the floor. So we use clean water for that. And we'll operate the plant, making sure all the cycles and everything kicks on when it's supposed to, when water levels happen. And we run it, through its whole process. We won't suddenly say, hey, everybody tie in and suddenly overflow the plant, because if we run into an issue, that's a lot of people you have to shut off, and then what do they do? So we phase in. So we have there's an apartment complex specifically that has pretty much laid everything to tie in except for made the final connection. They've put all the pipes in the ground. They'll probably be the first ones on. That'll give us that percentage of flow we need for that next test phase. If everything goes good, then we can bring in the condos. Again, a large amount of flow with minimal amount of connections. Gets us up a little bit more. If we pass that, then we send out the notices to connect to everybody else. Yes, once you get those, you have 90 days to tie in. There's things that people can do to speed up this process and maybe even save some money. If you're part of an HOA or just really know your neighbors really well, by all means, try to get together as a group and see if you can get a company to come in and do you all at once. You might get a better price because they're not unloading equipment multiple times. They can come in, set up, get all the pipe they need, or any other fittings they need to do the job, and go down the line and hit everybody on the road. And that might be a way to get a better cost and speed up the process.
Good suggestion. All right. Well, as I said before, Jared, I was very impressed. I was impressed with the size of it. I had no idea. And the fact that we've pre-planned for phases down the road. And there's a lot to it. You gave a great tour and a great explanation. We were out there for a few hours the other day. We're just giving you the basic recap.
Yep.
But, anything in closing that you'd like to bring up?
Well, like I said, I have an open door policy. It's kind of made my days hard sometimes, but I truly believe in that. I've had many people come to the town hall and they're like, oh, the wastewater department. And suddenly they knock on the door and they got questions. I'd rather have people come ask me the questions. Rumors do float around about many different things, and I'd rather just give you the straight answer and talk you off a ledge than to have you worrying about something that might not be nothing you have to worry about. So my door's always open if you got ideas. I actually had a gentleman come in this morning. That's when I was trying to prep for this. Stopped what I was doing to talk to him about the Pimlico Pond Road project we're looking at. And he was very excited about it and wanted to know some details because he works at a private development. They're getting ready to put in their own private plant, and it kind of coincides. So by all means, ideas or just have a question or a complaint, my door is always open. You're welcome anytime to come talk.
That's great to know. Jared, thank you very much for being here today.
Thank you.
We really appreciate it. Really appreciate the tour, and we hope to get back there as you get closer.
Absolutely.
Okay, great. So that's going to be it for today, folks. This is Chris Ball from Mashpee TV. We're signing off till we have the next Mashpee update. Thank you.